Namaste, this is SS Bhai. Welcome to MBWI. So first I will start with कि इस whatever I am doing कि इसकी utility क्या है. So from the perspective of utility, let me classify let me classify we have two types of people. So aspirants. Okay, so first beginner वो हैं जो जिन्होंने बिल्कुल भी ऑप्शनल को टच नहीं करा. दे आर जस्ट स्टार्टिंग विद द फिजिक्स ऑप्शनल. एंड सेकंड टाइप जो जिन्होंने कर लिया है कुछ, like they have already gone through the syllabus at least once. Okay, so these are the second kind. Now for the first kind, beginners कैसे, beginners को क्या advantage करेगा उनका भी बताऊंगा. और जो जो इस सेकंड वाली कैटेगरी लाइक मी, they have already done it, then उनको कैसे करेगा. तो beginners के लिए it will be a route map कि क्या पढ़ना है, कैसे पढ़ना है. और इनके लिए क्या होगा, इट इज अ रिवीजन और पीवाईक्यू कैसे करने. सो फॉर द बिगिनर यू जस्ट सी, डोंट वरी क्या समझ आ रहा है क्या नहीं आ रहा है. जस्ट एंड फ्रॉम दैट यू रेफर बुक, स्टैंडर्ड बुक, देन मेक योर ओन नोट्स एंड गो हैड. So this is the way. This will be the utility of these initiative that I have taken. Okay, so let's get started. First, I have done basic things like photoelectric effect, Compton effect, and wave aspect of particle. अब ये तीन चीजें हैं तो, और तो उसमें थॉमसन एक्सपेरिमेंट भी आता है. तो इसमें क्या है, लाइक व्हाई आई हैव स्टार्टेड विद दिस photoelectric effect. So this is basic premise that when you start with quantum mechanics, you must know why will it led to the quantum mechanics. Okay, so photoelectric effect very basic, you people know from class 12th. You just have to just define that अगर हम कुछ एनर्जी डालते हैं मेटल पे तो उसका कुछ वर्क फंक्शन होता है. जो वो एनर्जी वर्क फंक्शन के जितनी ऊपर होगी उतनी काइनेटिक एनर्जी से इलेक्ट्रॉन बाहर हो जाएगा. दैट इज व्हाट फोटोइलेक्ट्रिक इफेक्ट. नाउ कॉम्पटन इफेक्ट में क्या होता है, कॉम्पटन इफेक्ट में वी हैव रे that collide with electron, then we have final frequency of that ray, which is given by delta lambda f minus lambda I is equal to h upon m ec 1 minus cos theta. So derivation to it is derivation to this is standard problem in collision. Standard problem in collision. So in classical mechanics you will see that how to drive this. Okay, now photoelectric effect versus Compton effect में फर्क क्या है, that it is a low energy phenomena. What is low energy? Photoelectric effect is a low energy phenomena. Photon delivers its total amount of energy to a single electron, and that Compton effect is a mid energy phenomena, and the photon transfers part of its energy to a single electron, right? So this effect explained by Albert Einstein, everyone knows it, and this effect is explained by Arthur Compton. That's why name is Compton effect. The photon disappears after the interaction, but the wavelength in the Compton effect, the wavelength of the scattered photon is higher than that of incident photon. So this is the difference between the photoelectric effect and Compton effect. Okay, so now the thing now next thing comes that what is wave aspect of particle. So everyone knows that कि हमें पता है कि there is a duality, particle behaves like a wave and behaves like a particle, and so wave particle duality कहती है कि every particle or quantum entity may be described as either a particle or wave. Now there is a like it was proposed by de Broglie. So de Broglie proposed that like light energy matters also should have dual nature of wave and particle. The wave associated with matter is called matter wave or de Broglie wave. So the formula is lambda is equal to h upon p, where h is a Planck constant and k K vector is a wave vector, so K vector you can write P vector simply. The P vector is equal to H bar K vector. So you remember these formulas, they are very basic. Now we have a Devisor-German experiment. इसका aim क्या था कि it is to demonstrate wave particle duality of duality by diffracting a beam of electron. ठीक है, वी हैव डिवीजन जर्मर एक्सपेरिमेंट। इसमें क्या था कि हमें बहुत सारी थ्योरीज थी कि हमें मतलब किसी को समझ नहीं आ रहा था कि एक्चुअली होता क्या है। देन जे डेविन जर्मर केम एंड demonstrated a wave particle duality by diffracting a beam of electron. So we know that this equation, very basic equation, and lambda is equal to 2d sine theta, sine phi. So when this is an electron source and ray comes from with an angle theta by 2 with a perpendicular, and electron detects it, and this is a nickel crystal. Okay, so the now the calculation, how calculation is done, we consider that the beam of 54 electrons directed perpendicular to the Ni target, nickel target. Okay, perpendicular, this is perpendicular, so this is a 50 degree with the, and occurred at an angle 50 degree with the original. The electron distribution occurred at, okay. So now if theta is a 50, fine. Theta is a 50. Theta is a 50, then how will you find phi? Using this equation. Then phi is equal to 65 degree. Now considering n is equal to 1, we got lambda is equal to 1.66 angstrom. So using lambda is equal to h upon p, we will get lambda 1.6 angstrom. So thus electron wavelength is therefore in excellent agreement with the observed wavelength. Okay, so it was proved that it was the clear कर दिया था कि that we have wave particle duality. Okay, now this is just Thomson experiment. In Thomson experiment, what happens in Thomson experiment? Electron were deflected through a polycrystalline thin film. Diffraction fringes were also observed. These results confirm again the wave behavior of electrons. Okay, so the Thomson experiment also for the for to demonstrate the wave behavior of electron. See, electron is a particle. Electron is a particle, and if it is a dual behavior, it should also behave like wave. So that was demonstrated in these experiments. You have to just see how these data, you have to remember theta is 50 degree phi and that lambda 1.66, and this is a nickel crystal. Can anyone tell why nickel crystal? Okay, so this is the things that like precursor to the quantum mechanics, photoelectric effect, Compton effect, and wave aspect of particle, wave particle duality. Okay, so well, in this video just keep it with this, and again in the next video we will start with Heisenberg uncertainty principle. Okay, so let's stop here.